uh, yeah, two things: encapsulation, inheritance. A quick recap: encapsulation, as I said, binding the entire thing and not giving access for everything for everyone, making few things private, right? Setting private variable means it's a part of encapsulation. Like how we did bank balance. This is an example for encapsulation. This part is making a variable private is encapsulation. Okay. So that's encapsulation. Next, inheritance is whatever your parent has, you will get it. If you are a child of a parent, then you get whatever your parent has. Let's say you have a class A, let's say you have a class B. If you want to make this as a child of A, then just write A in front of that. That's it. Now B will become a child, A is a parent. Whatever A has, let's say A has three things, B has one thing, but in reality, B has one thing plus whatever parents has, 1 plus 3. Total 4 things B has. Okay, that's the meaning of inheritance. Whatever parents has, child will get it. When I say whatever has means two things, mainly two things: attributes and methods. That's what every class has, right? Nothing else. Even this class level attributes, object level attributes, class level methods, object level methods, everything. Whatever the parent has, everything it will get. So that is what inheritance is. Next pillar is polymorphism. What's the meaning of poly? Many. Poly means many. Morphism means forms. This is like a double acting movie, triple acting movie, or a Dashavataram. One person is having multiple characters. Okay. Best example is Dashavataram. Person is one only, but the character is many. Or Onion movie. Right. One person, multiple character. That is polymorphism. Poly means meaning, morphism means forms. Okay. Now, why this is in OOPS? What is the use of it? Yes. The method might be looking same, but it behaves differently in different places. For example, we were discussing a wedding situation, right? Let's say in that I have a method called eating method. This is class A, class B, all in the same program. Okay, class C. Class A has a method called eat. Def eat. Some logic. Same def eat. Same method there. Once again, def eat. Here, class A will be, let's say, South Indian wedding. Okay. Class B will be North Indian wedding. And class C, let's say an Italian wedding. We have three class. Three class also has the same method name. Eat, eat, eat. But the behavior of the method will be different. Here in South Indian wedding, the food will be different, right? When I say eat, let's say I'm saying print, I'm eating idli sambar. Okay? This is for South Indian wedding. When I say eat for North Indian wedding, I'm saying print, I'm eating roti curry. Okay? Italian, maybe Italian dish, I don't know anything. I'm eating Italian dish. As you can see, the method name is same only. Here also eat, here also eat, here also eat. But it's behaving differently in the different classes. That's the meaning of polymorphism. When I create object from this, object 1 equals to South Indian. Okay. And now if I call eat method from South Indian, here everyone self. This is mandatory. Writing self is mandatory. Object 1 dot eat. This will be printing. If I do here object 2 dot printing, object dot eat, this will be printed. If I do object 3 dot print, object 3 dot eat, this will be printed. So everywhere I am calling eat method only, but it is behaving differently accordingly. So that is the meaning of polymorphism. It looks same, but the behavior is different. Okay, so here the illustration is very simple. Method is same but behavior is different. That is the whole point. Okay, write this code down. Okay, look here. Let's take this scenario. Um, I have a class father. Father has a method work. Says I'm a father. A son class is there, inheriting the father. No logic, nothing. Just a class exists. Now if I create an object out of this class, if I do son one dot work, which means I don't have that method only, what will be printing? If I do this, is this an error or something will happen? Yeah. First write this down. Later we'll modify it. First write it, execute it, check what you are getting, the output. Okay, this is situation 1. The output of situation 1 is this. The reason behind that is this work belongs to its parent. The parent has that method, so whatever parent has, child also gets it. That's why even if the child doesn't have that method, still it is executing. Okay, that's because of inheritance, because of this part. Okay, now we are discussing what? Polymorphism. Yeah. Now we are discussing polymorphism. Inside a polymorphism, we are using inheritance. Now, since I said this is a situation 1, there is no polymorphism here. Polymorphism comes where I write for the situation 2, that is, I write the same method name here. Sorry. Now this is polymorphism. I have a multiple method with the same name. Now do this, tell me what is the output. Yes. Okay, this is situation 1. Here, when I do sun dot work, even if the sun doesn't have that method, still it is executing and I am getting that output. I am a farmer because of inheritance. Okay, there is no polymorphism there. When I come here to this situation, I create a same method, create a method with the same name, work. Okay, now this is polymorphism because same method with different behavior. Here it is behaving as a farmer, here it is behaving as an engineer. Now if I do sun dot work, previously I was getting I'm a farmer, now I'm an engineer. So there is a catch here. Okay, I have a class A and I have class B inheriting A, I have class C inheriting B, I have class D inheriting C, I have class E inheriting D. I have this situation. Now, let's say this has work method, this has work method, this has a farmer, engineer, doctor, okay? This doesn't have work, this doesn't have work. This is the situation. Now if I create an object out of E, if I do object equals to E, if I do object dot work, what will I get? Farmer, engineer or doctor? Write this code and tell me. Write this down. in the write this code also, another file. Just copy this and add this line. We'll come to this. Before that, this is very important concept. The situation 1, no polymorphism, only inheritance. Very straightforward, it works. This is inheritance plus polymorphism. We are inheriting here. Polymorphism happens because work, different behavior. When I do send.work, this is printing. I will tell why in this concept. Okay. Suppose when I do send.work, if I want my parent work to be triggered, then mine. Then you have to use super keyword. Yesterday I said anything to deal with your parent, use the super keyword. Just call, super means you are calling your parent. Dot work, what you want from that, what you want from your parent. You want to call this method, right? So if you do this super dot work, your parent's work will be called, this will be printed first, then this will be printed. This is very important. Okay. Now let's come to this. What is output for this? Yeah? No output? Sorry? No output. You're getting doctor? Let's run this. Yeah? Yes. One second. So you're getting doctor as output? No.
Directly in class only we decide.
Just pass. Speed equals to A. Okay, so this is the code what I write there, written there. Class A, work father, class B, inheriting A, inheriting B, inheriting C, inheriting D. Okay, so till here I have a work, I have a method, same method, which is polymorphism. Okay, and I am creating an object from E, okay, which is inheriting D, which is inheriting C, B, A. Now, if I do object dot work, E doesn't have, this object belongs to E, right? E doesn't have work, so it will check, does my parent have work? It will see, it will go here, it will go to D, it will see, do I have work? Do D have work? No, it doesn't have. Then it will go up, it will ask its parent, do C have work? Yes, it has. So this will be printed. So this method is called method resolution pattern. Method resolution. Just method resolution. Okay. This is the pattern it takes. First it will check, do I have that thing? No. Does my parent have? No. Does my grandparent have? No. Does my great grandparent have? Yes. Then that will be printed. So it will check in the linear way. It doesn't go directly to it. First it will check, do I have? No. Do parent have? Like this. It will. So wherever it gets the result immediately, it will stop there. So that's the flow, you should know. Okay. Now tell me, if you create an object out of C, and if you do object dot work, if you do object 2 equals to C, object 2 dot work, what will be printed? Creating object out of C and calling the method work, what will be printed? Which one? Sorry? Create another object equals to C and call or work from that particular object and see what is printing. What's the output? Yes. That's because first it asks, do I have that method? Yes, it has. It stops there. So question from this will come for interview, method resolution. You should know how it resolves the method. Okay. Now, next concept. Python natively doesn't support this feature, so we have to import something from some module. I'll tell how. Now know what is abstraction. Let's take a wedding situation only. We attend wedding and we go to the food counter, right? We doesn't care how the food is prepared, how much it costed, how many people are involved in it, what are the ingredients. We don't care all these things. We only care about if I sit here, if I go to the food counter, I get the food. This is what I know, right? I don't care what's happening behind the scene. I don't care what's happening in the behind scene. What I know is, if I do this, I get this. This is how you can explain abstraction. Okay? Whatever happening in the background, I don't care about it. I don't even know what is happening. I don't even want to know. We should not care. It's not only I don't care, we should not care also. We should not care what's happening behind the scene. All you have to know is, if I do this, I will get this. If I, for example, example is that only. If I sit in the, if I go to the food counter, all I know is I will get the food, but I don't care how it is cooked, what is happening. I don't care all these things. So that is the meaning of abstraction. Here in the programming terminology, the complex code, we will write it somewhere and hide it somewhere. The complex code. Complex code. For example, in the Swiggy, if I just press order button, all I know is if I press order button, I get food. I don't care how it's prepared. Who are involved? Customer don't need to know all these things. This part is there, right? This is what I call the complex part. I will hide it somewhere. I will only show the one button to the user. That is what the abstraction is. Every implementation part will be hidden. All the complex part will be hidden. Only the thing is, you should know, if I do this, this will happen. That's the main funda of abstraction. For example, like we use laptop only, right? All I know is if I double tap on the icon, app will open. I know this. I know what if I do this, this will happen. But I don't care how it is opening, what is happening in the background, how the RAM is involved in that, how is disk involved in that. I don't care all these things. I don't even want to know these things. Right? That is abstraction. So to implement this, I need to import something. In order to implement abstraction in Python, this line is mandatory. Without this line, abstraction won't happen. ABC means abstract base class. You can also say, I don't care about the how part. I don't care how it is happening, why it is happening. I don't care all these things. Everything will be hidden somewhere behind. All I know is what will happen if I do this. Only you should care about what part. Only what. How, why, we should not care. That's called abstraction. One good example in Python is, let's say you have a list, okay, 10, 5, 2, 4, 15, you have a list something like this. In order to sort it, we all just have to do L dot sort. This sort, all you know is, if I do this, if I do L dot sort, list will be sorted. All you know is, if I call sort method, list will get sorted. You should not care how it is sorting, why it is sorting, what's happening in background. No. This is an example for abstraction. All you see is just sort method. The code behind sort, you should not care. That is abstraction. Okay. I'll show how to implement abstraction class. This is mandatory from ABC. Import ABC abstract method. Okay. This line is mandatory by heart. Now let's create a class. Let's take a marriage only. Marriage class. To make this abstract, you have to inherit ABC. Unless you do this, marriage won't become an abstract class. Now you inherited it, the marriage class automatically becomes abstract class. Okay? Just to do this, just inherit this thing, this marriage will automatically become abstract class. Now in the abstract class, you should have a abstract method also. Write a method. Let's say perform marriage. Okay. Now we have a method, perform marriage method. Now to make this method as a abstract method, you have to write @abstract method. This is called decorators. One liner for decorator is, this is a compulsory question in interview. Suppose if you go a little higher package, one liner for decorator is like, it will change the behavior of the method. It will give extra behavior to the method. If you don't have this decorator, this will be a normal method. If you write a decorator, there is many different type of decorators. If you write a decorator here on top of the method, the behavior of this method will get updated according to what you do here. what you write in top of that. Now, since you wrote abstract method, this normal method automatically became an abstract method. Now this is an abstract method. This is the structure of an abstract class. All the abstract class will have this structure. You can by heart this. This is the structure. This line will be there, a class will be there. You have to mandatorily import this thing and inherit here. Then you should have an abstract method. To make a normal method into abstract method, just write the decorator on top of that. It will become abstract method. This is the structure. Write it down. Try to create one object for that method and try to create an object for this class and call this method. Super is a method, so you should have two copies. Create an object and call perform marriage. What's the output? Name error? No way. Yeah. So you get an error. The error says type error can't instantiate abstract class marriage. Can't instantiate abstract class marriage without an implementation for abstract method perform marriage. Now this says a lot of things. Let's break it down one by one. Can't instantiate. What is the meaning of it? Can't instantiate. What is the meaning of instance? Instance. Instance means I have another word. I have written in the code that way. I remember. Yeah? Yes. Correct. Instance means object. Whenever I say instance, I mean object. Both are same, okay? Cannot instantiate means I can't create an object. That will clear the first line. Abstract class marriage. So now it's clearly saying marriage is an abstract class without an implementation. For abstract method, perform marriage. For perform marriage method, it is saying we have to implement it. I wrote just pass there. I did not implement it. So this says if I have a abstract class and an abstract method, implementation is mandatory. Okay? I can't leave it like passive. Implementation is mandatory. To implement, let's create a child class. Do you have a charger? Yeah. Okay, this is like a structure. Okay, this is how you have to follow it. If you have an abstract class and if you have an abstract method, then you have to inherit and do the implementation in the child class. This is the structure you have to follow. Okay, so an important interview question here. Most of the interview they will ask this question: can we create a object? Can we instantiate abstract class? Can we create object from abstract class? The answer is no. That's how it is designed only. It's by design, it's like that only. One more important point. Try to run this code. It will throw an error. Why? Because very important point here. Listen carefully. You have an abstract class. You have an abstract method. Now you inherited something. Inherited the abstract class. If you inherit abstract class, it is mandatory that you have to do the implementation of an abstract method. You cannot leave it. You have to implement it. That's a rule. If you inherit abstract class, you have to implement abstract method. This is also interview question. They will give this code snippet and they will ask the output. What is the expected output? The output is like cannot instantiate without implementation. That's the answer. This is the output. So whenever the abstraction concept comes, two things you should not forget at all. First thing is you cannot create an object from the abstract class. Second thing, if you inherit the abstract class, you have to implement abstract method. Two rules. Mostly asked interview question. If you're done, you can leave.